Hello, I am Kanna, welcoming you all for this NIA Storage Conference. And my presentation topic is 0 to 100, enabling disaster recovery for Kubernetes with Ceph 3.0. Before deep diving into our session, I like to say few words about MSys technologies. MSys Technologies specializes in product engineering services and digital transformation. And we are working with all top storage companies and all top enterprises like Amazon, Google, Perth. And we are getting a lot of awards like Lead Referring 100, Top 100, and IE20 Top Winner Awards. And also MSys is one of the top fastest growing storage companies for 2 consecutive years. And we have the offices across different locations that spread across the world. Okay, now let's see the agenda of our session. First, we are going to see about Ceph and Ceph architecture and the components of Ceph. I'm going to see about the Ceph algorithm. Then we are going to see about Rook CEPH and its components. Then Ceph RBD Mirroring and the types and replication types in it, and what is ArgoCD and what are the features available in it. Then we are going to see about setting up Ceph RBD cluster with examples. And after that, we are going to see about integrate Kubernetes platform with Rook CEPH. Okay, Ceph is an open source software storage platform. It implements object storage on a distributed computer cluster and provides an interface for block, object, and file storage. It is a distributed storage system that is massively scalable and high performing. And the main point here is there is no single point of failure. And also it runs on any hardware that matches its requirements. This is the Ceph architecture, and in this architecture, the Ceph clients can be categorized into 3 types: apps, host, VM, clients. And also we have 4 ways of accessing a Ceph storage cluster: LibreDOS, RADOS Gateway, RBD, and Ceph file system. The RADOS Gateway provides a RESTful gateway to Ceph storage cluster, and it supports 2 interfaces: Amazon S3 API and OpenStack Swift API. RBD is the RADOS block device. It provides a Ceph storage cluster as a block device so that the clients can able to access the cluster. And in the Ceph file system, client can access the cluster through POSIX interface, like how they access the typical file systems. And LibreDOS is a library that allows apps to directly access RADOS with support of C, C++, Java, Ruby, Python, and PHP. And there is a different types of components is there in the Ceph. They are Ceph monitors, Ceph object store devices, Ceph managers, and reliable autonomic distributed object stores. Now let's see how each one plays the role in the Ceph cluster. Okay, Ceph monitor is responsible for cluster quorums. And all the cluster nodes report to monitor nodes, and share the information about every change in their state. And the OSP, Ceph Object Store Devices, is responsible for storing objects on local file systems and providing access to them over the network. And Ceph clients can interact with OSDs directly. And Ceph managers provides additional monitoring and interfaces to external monitoring and management systems. The RADAS, Reliable Autonomic Distributed Object Stores, is a core of Ceph storage clusters. This layer makes sure that stored data always remains consistent. And also it is responsible for performs data replication, failure detection, and recovery. So in the Ceph, how we can write data from and to a Ceph cluster. The client first will contact the Ceph monitor to obtain the recent copy of the cluster map. That cluster map contains the cluster topology as well as the data storage locations. Ceph clients use the cluster map to figure out which OSD we need to interact with and initiate a connection with the associated OSD. The CRUSH. CRUSH is the controlled replication under scalable hashing. It is a hash-based algorithm for calculating how and where to store and retrieve the data. Basically, Ceph uses CRUSH algorithm to achieve a data redundancy in storage cluster. And this CRUSH replace the role of controller to achieve data redundancy. By this way, we can avoid the dependency of the vendors. And it allows to build a data storage cluster that has high scalability and flexibility. And this Ceph CRUSH distributes data evenly across available storage devices and allows clients to communicate directly with the storage device. Now we can see about Rook CEPH and how it's using in the Ceph cluster with Kubernetes. Rook is a storage apparatus for Kubernetes. It uses the open source Ceph scale-out storage platform and Kubernetes, which provides the dynamic storage environment. And also, it turns distributed storage systems into self-scaling, self-healing, self-managing storage services. It automates deployment, scaling, upgrading, migration, monitoring, and resource management. It is a framework for storage providers to integrate their solutions into cloud-native environments. Now we can see what are the different Rook components and what roles they are playing. Rook operator, Rook agents, Rook discovers are the different components in the Rook. Okay, Rook operator is the core of Rook. Basically, it is a container that automatically bootstraps the storage clusters and monitor the storage demands. And also it create and manage our storage cluster through CRDs. And the Rook agents run on each storage node and it handles all storage operations. So it is responsible for attaching storage devices, mounting volumes on the host, and formatting the file system. Then comes to Rook discovers, it detects storage devices attached to the storage node. And also Rook plays the main role to deploy Ceph Monitor, Ceph OSG, and MGR, that is the Ceph Manager daemons for the Ceph clusters as Kubernetes pods. Ceph RBD Mirroring. In Ceph RBD Mirroring, we can use the RBD images and it can be asynchronously mirrored between two Ceph clusters. And it is available in two modes. One is the journal based and another one is the snapshot based. And it can be configured as one-way replication and two-way replication. In one-way replication, data is only mirrored from a primary to secondary cluster. And also the RBD mirror daemon runs only on the secondary clusters. But in the case of two-way replication, data is mirrored from primary images on one cluster to non-primary images on another cluster and vice versa. And here the RBD mirror daemon runs on both the clusters. And now we can see what is ArgoCD and what are the features available in it. ArgoCD is a declarative GitOps continuous delivery tool for Kubernetes. It implemented as a Kubernetes controller which continuously monitors running applications and provide complete details about the applications which we can compare the current value against the desired target values. And the ArgoCD helps us to automate deployment of application to specified target environment, and it support for multiple config management and templating tools like Helm, KSonnet, JSonnet, Plain YAML. And in our example, we are going to see about Helm, how we are using it. And also by using ArgoCD, its ability to manage and deploy the multiple clusters, and it provides multiple tenancy and RBAC policies for authorization. And also we can roll back and roll anywhere to any application configurations. And we can get the complete health status analysis of all the application resources. And also we can automated or manual syncing of applications to that desired state. And it provides the web UI. By using this, we can get the complete details of the real-time application activities. Now we are going to see how we are setting up the Ceph RBD cluster with examples. On the high level, how we are installing the RBD cluster is by install Rook Ceph using physical devices or Kubernetes storage classes that can provide block volumes. A database, in our case, we are using REDIS, using Rook CEPH and installing the Kubernetes platform K10 to back up the database. Here we are using Rook version 1.4 and Ceph version 3.0. And to start with, we deployed the Rook operator and then Ceph cluster resource. After we did that, we are cloned the Rook GitHub repo and changed the directory to this. Then after completed it, we are creating all the common resource, which includes Rook default deployment namespace and required custom resource definitions. It will CRDs. Okay, once all the common resources created, we deploying the Rook operators. And we can verify the Rook operator deployed on the Rook Ceph namespace successfully. Once the operator is successfully installed, we created the Ceph cluster. And here the Ceph installed via Rook can be backed up by either physical devices that mounted on the Kubernetes or by using the existing storage provider using PVC. And in our example, we have created cluster by using the existing storage provider. And also we can verify the Ceph cluster is installed successfully or not. And also we can check the health of the cluster by running this command. And we can see the health state is fine in our example. And after Rook operator and the Ceph clusters have been created, we created the storage class and the volume snapshot class to define the newly created storage provisioners. And the important change in the Ceph version 3.0 is support for Ceph RBD snapshots. And also it supports the stable Kubernetes snapshot beta API. How we can confirm this? Whether really it supports all this in the 3.0 version. We confirm this by describing the volume snapshot class that was created and looking for the V1 beta 1 API version specifications. And here we are using Rook CEPH RBD storage class. Rook CEPH block is the default storage class for use with REDIS and K8s. Okay, now we are going to see how we are integrating the Kubernetes platform. In our case, it is a K10 with Rook CEPH. As we already see in the ArgoCD, right? Here we are using Helm to install Kubernetes platform K10 by using these commands. And after this, we annotate the newly created volume snapshot classes so that Kubernetes platform K10 uses it when creating a snapshot of Rook CEPH volumes. Now we can see how we are taking the backup and restore the Redis application. As we see, right, we are already started the Kubernetes platform K10. Now it is up and running. After that, we first install the Redis and then use the Kubernetes platform K10 to take the backup. And to make sure the volume for Redis was provisioned through the storage class Rook CEPH block. List the persistent volume claims from Redis namespace. Here we can see the list. And after Redis is installed, we access the Kubernetes platform dashboard via the port forward command. Here we can see this, the port forward command. And we access the Kubernetes platform K8s dashboard through browser as well by using this link. And Redis application can be seen in the application code from the main dashboard. And here we can see the Redis applications, and we can click on this snapshot icon for the Redis application to take a snapshot of the application and its data. So once we clicked on the snapshot, we can see here the snapshot is getting started. And also we can see the progress in the dashboard. And we can view the action status from the main dashboard. And also in major all public clouds, these snapshots are durable. And also we can treat it as a backup. So once the backup is completed, we can go back to the application code to check the restore point for the snapshot what we created. So now you click on the restore button, that will show all the restore point for Redis. Then you click on the restore point code to restore the backup. So once we did that, we get the notification and also able to see the restore job progress in the Kubernetes dashboard. So once after the job gets created, we can see the restore details, everything in the dashboard screen. By this way, we achieve the disaster recovery by using Kubernetes with Ceph 3.0. And we all know, right, what are the new features and enhancement in the Ceph 3.0. Just I want to go through some basic features, and there they implemented a lot of enhancements as well. So in Ceph 3.0, it support create and delete snapshot for RBD, and create PVC from RBD snapshot, and create PVC from RBD PVC, and add support for multiple FS subvolume groups and multi-architecture Docker images, and support read-only many for PVC for RBD, and same for the Ceph file system. And apart from this, they are supporting a lot of enhancements as well in the Ceph 3.0 versions. And these are the references I went through for this presentation. And I like to say few words about me. I am Kanna, right now working as a senior test manager, and I have 14 plus years of experience in the storage domain. And I have very vast experience in testing multiple storage vendor products. And currently more I am working towards the cloud storage with the AML projects. And also I have very good experience on Ceph storage, Kubernetes, and also Terraform. By using that, we can manage multiple cloud infrastructure. And also I am an Oracle Cloud certified practitioner and certified Scrum Master. And this is my LinkedIn and mail ID. So if you have any questions, And if you want to know more details about this, you always contact me. And also please rate this session. And before I am closing my session, I like to say thank you for the SNIA conference providing this opportunity to talk about my presentation. And also thanks to everyone who attended this session and watched this session. Again, thanks to everyone.